say all this again. So let me just summarize. So there are explicit and implicit equations. Equations that are explicit are solved for one of the variables. Equations that are implicit are not solved for any of the variables. So the example of an implicit equation would be x squared plus y squared equals 25. If you look at this, it's a circle with radius 5. Now, unfortunately, when you graph it, it doesn't pass the vertical line test because it's not a function. However, you can solve that equation for one of the variables, like what I did over here in blue, and you get y equals the square root of 25 minus x. If you graph this, you'll see that it's the top half of the circle, and you do get a function. With the techniques that we have so far, we do know how to take the derivative of the one on the left. We don't know how to take the derivative and find the one on the right, so that's what we're going to do now. So let's do an example. We're going to find dy dx for the equation below. Now let's say that the equation is x squared plus y squared equals 25. So that's the circle that we just talked about. Okay, so this is what you do. You take your whole equation and you take the derivative of x on both sides. So I'm going to have to take the derivative of x on the left and I'm going to have to take the derivative of with respect to x on the right. Okay, what happens on the right hand side? What's the derivative of 25? You get 0 because it's the derivative of a constant. Now on the left, you can split it up into two of them. You can take the derivative with respect to x of x squared, and then you can add, because the sum rule, the derivative with respect to x of y squared. Okay, now, the one on the left, I'm taking the derivative with respect to x of x squared. The variables match, so this is the regular derivative. The one on the right, there's an issue. I'm taking the derivative with respect to x of y squared. So what sort of derivative do you have to, what's the type of derivation you're going to use when the variable of the thing that you're taking the derivative of does not match with the thing that you're taking the derivative with respect to? This is implicit differentiation, which basically means that you're going to use the chain rule. Okay, so let's do the derivative with respect to x of x squared. That is just 2x. Take the derivative with respect to x of y squared. Okay. So the chain rule tells you you're going to have to take the derivative with respect to x of y squared. And then what you're going to have to multiply by is the derivative of y with respect to x. Or say, I'm sorry, I did this wrong. My bad. You have to take the derivative with respect to y of y squared. Do you see how they match now? I'm taking the derivative of y squared with respect to y. The independent variable of y matches with what you're taking the derivative with respect to. Okay. Now you have to multiply by dy dx. Because what's going to happen with this dy right here and that dy right there? They like cancel, and then you get the derivative of y squared with respect to x. Okay, so what is the derivative of y squared with respect to y? What is that? Yep. And then dy dx just stays as dy dx. Okay, now what you do is you plug these into your equation. The derivative of x squared with respect to x is 2x. The derivative of y squared with respect to x is 2y times dy dx, and it's all equal to 0 because you had the constant over there. Okay, so remember we were asked to find dy dx for the equation below, so that's what we're going to solve for in this equation. Here is the thing that I want. I want to know what dy dx is equal to. That's my derivative. It gives me the slope of my tangent line. So all we have to do is solve this equation for it. So you get 2y dy dx equals minus 2x. Right, see, I just moved the 2x over. You can divide both sides by y, and you get y times... I'm sorry, you can divide both sides by 2, and you get y times dy dx equals minus x. And then you could divide by y. dy dx equals minus x over y. And I'm done. Okay, and I'm going to show you what this gives you. It's actually pretty cool. Okay, so I'm going to open up a Wolfram. So 1 second while I do that. Oh my god, burrito. Okay, 1 second. Oh, how do you do an implicit plot? Okay, just 1 second. Sorry, I'm having a hard time getting this to plot. Okay, so let me change my screen. Okay, cool. So do you see how here I have the graph of a circle? The graph of the circle? So what we just found out was that dy dx equals, what was it, minus x over y. Okay, so let's say you take a point on the circle, like right here. Let's see, can I mark it up? Please let me. Drawing tools, there we go. So let me use. So let's take this point right here. Hopefully you can see the dot at come on, let me draw. At oh, okay, that's not what I want. I just want to like. Okay, that lets me put dots. That's not what I want. Why is it not letting me just like draw random stuff? Oh, there, this. There we go. Here's our point at. I keep selecting it at 0, comma 5, Notice that's an x and y point. Oh my god, I'm so sorry. This is like so hard to draw on here because it makes me reselect the drawing tool every time I draw anything. It's killing me. Okay, so if you look at that point right there, if you were to draw a tangent line, what do you think the slope would be? Like through that point, 0, 5. Yeah, because the tangent line would look something like this. Okay, now we have a formula for this. So if you plug in the x value, which is 0, oops, okay, I selected the wrong thing, my bad. You get minus 0 over 5. And what does that become? 0. So that formula dy dx actually gives you the slope of the tangent line and at any point on the circle. So let's choose some other random point, like let's choose this point right here. So what might the x and y values of that point be? Or let's I know what we'll do. Let's solve the equation. We're going to solve, if the x value equals 1, what's the y value? So you would get 1 plus y squared equals 5. Solve for y. Oh, cool. So you get the point 1, 2. So let's say you have this point right here. Actually, 1, 2 is more like over here. One comma 2. Wait, that doesn't make a lot of sense. If you plug in the x is 1. Oh, 5 squared. I'm supposed to put it equal to 25. No wonder. Sorry, my bad. Okay, so if the y value is 1, the x value is 1, the y value is 2 root 6. So let's put a point like right here. Draw a little line. Sorry, I'm having like major difficulties. And that point is 1, 2 root 6. Okay, so if you wanted to find the slope of the tangent line at that point, you would plug into the formula dy dx equals minus x over y. So you would get minus x, which is 1, divided by y, which is 2 root 6. Whatever that value is the slope of the tangent line right there. Minus 1 over 2 root 6 is the slope of the tangent line right there, which is actually sort of interesting.